Hello dear students, good morning. Today we are going to discuss about the halogenation reaction of alkene. Halogenation reaction, halogenation reaction of alkene, halogenation reaction of alkene. Okay, at first we have to know about the reagent we are using. Reagent, which reagent we are going to use is X2 and CCl4 as medium. CCl4 as medium. That is reaction medium or reaction solvent. We can use CH2Cl2 also in instead of the CCl4. Okay. Now X2 may be chlorine or bromine or iodine. If we want to want to make reaction with chlorine, then this reaction will be chlorination, and if we make reaction with bromine, then the reaction should be bromination, and if we make the reaction with iodine, then the reaction should be iodination reaction. Okay. Now at first we can look into the reaction scheme, that is H2 and CCl4. If we add, then what will produce? That is this is Cl. If we use Cl, then here Cl will be, but if we use X2, then here one X and there one X. Okay. So for chlorination, that is here one Cl, here another one Cl. If for the bromination, if we take here Br2, then here one Br, here another Br. Clear? If we take I2, then here one I and here another I must be here. Clear or not? Now, what type of mechanism it follow? What type of mechanism it follow? Mechanism is going through the non-classical carbocation. Non-classical carbocation. What type of carbocation? That is non-classical carbocation. Actual carbocation is not found here. Okay. And what type of intermediate will be found? Intermediate. And intermediate is called halogen intermediate. Halogen intermediate. Halogen intermediate. Intermediate. Halogen intermediate. Okay. So if we are going to make reaction with Cl2, then the intermediate should be chloronium. If we use Br2, then the intermediate should be bromonium. If we use iodine, then the intermediate will be iodonium intermediate. Okay. So for this reaction, we can see the reagent is X2 and CCl4, and CCl4 is the medium. And what is X2? That is X2 may be Cl2, Br2 or I2, and the reaction scheme is like this, that once X attached at this carbon, and another X is attached at this carbon, that means this carbon. Clear? And that is anti-Fasson addition. Anti-Fasson addition or anti-addition. It is one type of anti-addition reaction. Clear? So we have to go through the proper mechanism so that we can easily understand how this anti-addition or anti-addition product will be formed. Okay, now if we go to the proper mechanism, then we can see it is an alkene. Okay, and we are taking CCl for medium, and if we add chlorine, then the reaction start with the donation of this electron pair of this double bond into the vacant d orbital of chlorine, and at the same time the lone pair of chlorine will attack to the carbon. Okay, and at the same time the chlorine will be removed from this Cl2, and it makes another compound or intermediate like chloronium intermediate. This is chloronium intermediate. Chloronium intermediate. Intermediate. Chloronium intermediate. Okay. As we can see, in this chloronium intermediate, chlorine exists as positive charge. Okay. As we know, chlorine is highly electronegative substance. So positive charge on this atom is highly unstable. Okay, that's why this chlorine atom will attract electron density from this carbon and this carbon. Now we have to see the carbon which can easily or which can more donate electron pair to this Cl plus. Okay, as you can see that R is plus R affected group, that is alkene group, that's alkyl group, right? If alkyl group is attached with this carbon, then positive charge will be more stabilized by this carbon, right? As for plus I effect, this will donate electron pair to this carbon, right? That's why it make it in another type of intermediate like situation, that is Cl R delta positive charge. Why this carbon? Why this carbon delta positive? Because this delta positive charge will be more stable compared to this one Cl delta positive. As this carbon is less substituted and this carbon is more substituted, and more substituted carbon contain more alkyl group, and more alkyl group means more plus I affected group. Okay, as more plus I affected group is attached with this carbon, then delta positive charge will be more stabilized by this carbon, or at this carbon delta positive charge is more stable. Okay, this is more stable. So from this one, this make these. Okay, and these structures are called bridged, or this structure called, especially it will be formed, that is Cl this. Okay, this structure is called non-classical carbocation. Non-classical carbocation. Non-classical carbocation. Clear? As this is non-classical carbocation, and another Cl minus is there which was removed from Cl2. Now attack on the more substituted carbon. Clear? Attack on more substituted carbon. Substituted carbon. Clear? More substituted carbon, and it gives here chlorine, and here another chlorine. Clear? Here a chlorine and here another chlorine. If we start with Br2, then here one bromine, here another bromine will be attached. Clear? If we start with iodine, then here one iodine and here another one iodine will be attached. Clear? So by this way we can find that the addition is anti-type, anti-addition type, anti-addition type. Clear? So we can revise one time that this is an alkene, okay, and this alkene we mixed with Cl2 in CCl4 medium. Clear? And CCl4 is inert medium here, and chlorine start reaction with this type of cyclic intermediate, and this cyclic intermediate make these non-classical carbocations. Okay, then this non-classical carbocation, as you can see, this bond is larger compared to this bond. So here delta positive charge. Why this position delta positive charge? Because at this carbon delta positive charge will be more stabilized by plus I affected alkyl group. Clear? And next the Cl minus, which was removed from this Cl2, will attack on this carbon, and this carbon, the speciality of this carbon is highly more substituted carbon compared to this carbon. Clear? And now the final product is anti-addition product, that is chlorine and two chlorine atom attached, and the bond and the dihedral angle should be 180 degree. What type of angle? That is dihedral angle should be 180 degree. Clear? Now if we look into the type of various type of alkene, that is cis alkene and trans alkene, some questions are coming that from cis alkene which type of products will be there, that is DL pair or meso compound. Clear? And for trans alkene which type of product will be there, that is meso compound or DL pair. Clear? So we will discuss about the questions, that is question CH3 double bond CH3 hydrogen here Cl2 CCl4, which type of product we have to remember that this is cis alkene, and this is trans addition not, that is anti addition, right? That is anti addition. Cis alkene anti addition will produce DL pair. And what the DL pair is called, that is racemic mixture. Actually what type of product exactly found here, that is CH3 Br H CH3 and CH3 Br H Br CH3. Clear? If we calculate or find out the configuration of these two carbon and these two carbon, we can find that 1 2 3 according to CIP rule, that is 1 2 3 clockwise rotation, and fourth priority group is in horizontal, that is S, and this is also 1 2 3 clockwise, fourth priority group horizontal, that is also S. For this 1 2 3 anti-clockwise and fourth priority group is in horizontal, that is R. 1 2 1 2 3 that is anti-clockwise and fourth priority group is in horizontal, that is R. So these are mirror images. Clear? And we can find these two from this, and when we are adding Cl2 in medium CCl4. Clear? We can find them from the mechanism we have told earlier. Clear? And another one question is coming, that for transalkene which type of product is there. Clear? So now we will discuss about the transalkene. That is transalkene CH3, H Cl2 CCl4. Which type of product? Clear? Now here this is transalkene, and this is anti-addition. What type of addition? Anti-addition. You have to remember, transalkene anti-addition will produce meso compound. Clear? And what is meso compound? Meso compound is optically internally compensated. Clear? What is optically internally compensated? Optically internally compensated. Optically internally compensated. Clear? So what is optically internally compensated? Here product from the previous mechanism we can find that CH3 Cl H CH3 and CH3 Cl CH3 H, and here a sigma plane will be there. Sigma plane means plane of symmetry. Clear? As plane of symmetry is passing through this, and if we find the configuration, that is 1 2 3 clockwise rotation, and fourth priority group is in horizontal, that is S, and this is 1 2 3 anti-clockwise rotation, and fourth priority group is in horizontal, that is R, and followed by this S, and this is R. So this is internally compensated. Clear? It is S and it is R, and having one sigma plane. Here also same. Clear? If plane polarized light for this S make clockwise rotation, then it will make anti-clockwise rotation. Similar type for this. That's why these are called internally compensated. So for transalkene, anti-addition make meso compound. Clear? So we can concise it like that. Cis-alkene, that is symmetrical alkene, symmetrical alkene, X2 CCl4 DL pair, products are DL pair, and transalkene is here also symmetrical alkene, and here also what we find, that is meso compound. Meso compound. Clear? So by this way, we have completed the normal mechanism and how the anti-Fasson reaction occur and what will be the major product or what will be the products exactly from cis alkene and trans alkene for the halogenation reaction of alkene. Clear? I hope you understand. Okay, thank you.